Hi guys, today we're going to talk about families in the periodic table. So we've already colored our periodic table, and the first group that we colored was the alkali metals, so that's in group 1, the very first group. And some examples of group 1 are like sodium or lithium or potassium, cesium, francium. These are very, very soft. You can actually cut most of them just with a knife. And hopefully I can show you at some point, I'll bring out some sodium or potassium, and I'll show you that you can cut it with a knife, which is not what you think of when you think of a metal. You think it's like hard, but group 1 metals are actually very soft. They're also very shiny and malleable and good conductors, just like all the other metals. They are extremely reactive though, and so when we have a sample of sodium, we can't just leave it out. It's very reactive, and so we have to keep it in oil. Because they are so reactive, you will never find them in their elemental form. About 25 years ago, one of the my mentor teachers was telling me a story that we actually had a piece of sodium out in the lab, and one of the students kind of stole it and snuck it into their pocket, and they went to school and they went to their next class, and later in the day, they just like suddenly screamed while they're in like math class, and it had reacted in their pocket with the moisture that's in the air, and it started irritating their skin. So they're extremely, extremely reactive. So you'll never like go hiking and find a chunk of sodium sitting on a rock, because it would have reacted and turned into something else, a compound that has that. I wanted to show you a little video of sodium in water. So there's about a kilogram of sodium, which is 2.2 pounds, and they're throwing it into a lake. And you look at it, smoking a little bit, and then it ignites and it explodes. Basically, one of the reasons why it explodes is because there's hydrogen gas being generated there, and hydrogen gas is an explosive. Now, just to point out here, an element behaves very, very differently when it's in elemental form versus when it's in a compound. So, for example, sodium we just saw is extremely reactive. However, you have sodium chloride which is salt that you eat every day, and it doesn't explode in your mouth. And so it's very, very different when it's in its elemental form versus when it's in a compound. Most of the time, that makes it more stable. Let's look at the next group. So the next group is the alkaline earth metals, which is group 2. So things like magnesium, calcium, barium, strontium. These are soft, but they're not as soft as group 1. So you can probably cut them with a sharp knife, but not like with just a butter knife. They're shiny, malleable, good conductors, just like all the other metals. And they are pretty reactive, but they're not as reactive as group 1. So, for example, if you took a piece of calcium and put it in water, it's going to bubble a little bit, and it's going to generate hydrogen gas, but it's kind of slow, but you will see some bubbling. Again, to compare between the elemental form and the compound, where do we have calcium? We have calcium in our bones, right? But it's in a calcium compound. It's a calcium ion that's in your bones, and so it's much more stable. Your body's full of water. You don't want it to react, right? So in its elemental form, they're very reactive, but when they're in a compound, their properties change. Next are transition metals. So those are group 3 through 12. There are 10 groups of the transition metals. So these are the metals that you think of when you hear the word metal. So copper, gold, iron, cobalt, nickel, platinum. These are hard, just like what we think of as metals. They are shiny and they're malleable and good conductors. And they are way, way less reactive than groups 1 and 2. So if you put a chunk of gold in water, nothing's going to happen. If you put a chunk of iron in water, nothing's going to happen for a while. Eventually it's going to rust, but it's going to take a really long time. So way less reactive than groups 1 and 2. Because they are not as reactive, they are used for things that we, use in our everyday life, like jewelry. You wouldn't want to wear a necklace and then it reacts with your skin. We use them for construction. You don't want, to build a bridge out of calcium and, when it rains, it starts bubbling and reacting, right? So these are used for construction and jewelry and devices that we use and things like that in our daily life. And because of that, we think of metals as these transition metals. Now there are the inner transition metals, which are also called the lanthanoids and actinoids. And these include things like uranium, thorium, mendelevium, einsteinium. They are shiny, malleable, and good conductors, just like all the other metals. A lot of them have radioactive isotopes, and so sometimes they're used in nuclear reactions. Sometimes they're used as lasers or sunglass lenses or strong magnets. If you have a really strong magnet, it's likely that it's made out of neodymium, which is Nd, one of the inner transition metals. Now, the reason why we call them inner transition metals is because they're kind of like inside of the periodic table. So the normal periodic table that we see usually has, so there's group 1, group 2, the green, those are the transition metals. The inner transition metals are these two right here. And in reality, they do not belong there. They actually belong right here. So there's group 1, group 2. These are the transition metals. The inner transition metals are kind of inside in the middle of the periodic table. The only reason why we take them out and put them at the bottom like this is so that the periodic table is not, really skinny, so it can fit on a piece of paper and we can print it. And so the real periodic table actually looks like this with the inner transition metals right in there. The next group that we're going to talk about are the halogens, and those are group 17, so the group that's before last. So if you look at these right here, this would be group 17. These are the halogens, so fluorine, chlorine, bromine, iodine. Acetine is not really considered a halogen because it behaves a little bit differently. It's the rarest element anyways, so they don't know much about it. Anyway, so fluorine, chlorine, bromine, and iodine, these are very colorful. So most of the elements that we have around us in their elemental form are either white, gray, or black. There's not very many colorful elements. The exceptions are maybe like gold and copper. They're a little bit colorful. Sulfur is also yellow. I don't know if you can see that very well. This is sulfur. It's yellow. The only other elements that are colorful are the halogens. So fluorine and chlorine are these yellow gases. Bromine, I have a tube of bromine here, is actually a liquid at room temperature, but if you have just a tiny bit in a big container like this, it usually kind of vaporizes. So it's like an orange, reddish orange color. And iodine is, I thought I had a sample of it here, maybe not. Iodine is actually this very, very dark purple solid that, because it's so dark, it almost looks black, but if you dissolve the iodine in water or in a solution like hexane or something like that, then you can see that it's purple. So these are really, really colorful, which is not common for the elements on the periodic table. These are the most reactive of the nonmetals. So the most reactive metals are group 1, the alkali metals. The most reactive nonmetals are group 17. So imagine if you take a piece of sodium, that's a very reactive metal, and a piece of chlorine, that's an extremely reactive nonmetal. Chlorine is actually mustard gas, very dangerous. You put them together and you make sodium chloride, NaCl, which is table salt, which we all eat every day and are needed to regulate our heart and everything. So again, it's amazing how the properties of elements change dramatically when they're in their elemental form versus in a compound. Noble gases are group 18. They're the very last group on the periodic table, all the way to the right side. They include helium, neon, argon, xenon, radon. They are called noble gases because they're gases at room temperature. They are colorless, so you can't really tell that they're there. They're odorless, so they're colorless, odorless gases. And they are extremely stable. That's why they call them noble, because they're very, very hard to react. Noble men back in the day used to not associate with commoners. They just wanted to be by themselves. They didn't really do much. They just sat there. And so noble gases are kind of the same way. They just sit there. They don't really react. They don't want to associate with any of the other elements. They don't want to combine with them to form a reaction. They just want to sit there and they're happy the way they are. So sometimes we also call them inert gases. Inert means they don't react. So that is it for the families of the periodic table. I'll see you guys next time. Bye.